Okay, hi everyone. I hope you can hear me now, and we can begin. One sec. So, hi, my name is Alina. I'm a developer advocate for GraalVM at Oracle Labs. Super excited to be here. I love Devoxx, I love Poland, and I'm enjoying this conference quite a bit, and hope so are you. So, in this session, we'll talk about GraalVM and what it can offer for you as for Java developers, and in particular, how you can build Java applications that are great for deploying to the cloud with GraalVM. So let's begin. First things first, GraalVM is a big project, and there are so many things that you can do with it if you're a Java developer. So I want to show you quite a few ways of the things that you can do with GraalVM, and then we will focus specifically on native image. So one thing you can do with GraalVM is you can get more performance in the JIT mode, and that is meaning that you can use it as your normal JDK distribution. So if you are using, let's say, OpenJDK, you might as well swap your JDK for GraalVM, get all the same tools, all the same capabilities, all the same libraries working for you as is, and not to do any migration efforts to do it. So just replace it and get more performance if you're running on GraalVM. Because comparing to OpenJDK, and in particular Hotspot VM and C2, GraalVM has a new, highly optimizing Graal compiler developed by our team, created from scratch, and it has quite a few new additional performance optimizations that can make many Java applications run faster, even in JIT mode. So that is one big thing that you can do with GraalVM. Now, another big thing is the native image, which I'm sure many of you have heard of, and that is that mode of operation where you compile the application ahead of time into a native executable that will start very fast, use very little memory, and will be great for cloud deployments. And last but not least, GraalVM is also a polyglot VM. So in addition to Java and traditional JVM languages, there are many, many languages that you can run on GraalVM, and all of them will be performing with high performance on GraalVM. So to illustrate the thought, here are the languages that you can run on GraalVM. So Java, JVM, that is the normal execution in the context of OpenJDK or on native image. And also, since we have our own language implementation framework called Truffle, we can also run all those languages such as JavaScript, Ruby, Python, and R. So those are few supported and developed by our team. And also there is something like, 20 more languages supported and developed by the community, because it's fairly easy to implement and create new language on GraalVM comparing to creating from scratch, because you get all those additional tools, such as compiler, for example, out of the box from GraalVM. And what's interesting about GraalVM, it's also highly embeddable. So we can use it in the context of OpenJDK, right, where we just replace the top-tier compiler. But also, you can use it embedded in Node.js to run unmodified, normal Node.js application. Or what's quite interesting, we also embedded it in a database, more specifically Oracle database. So you can leverage GraalVM languages such as JavaScript in the database where your data resides. And last but not least is this standalone mode of operation, where GraalVM is the only runtime that you need to run your Java application. That is this native image mode, which is completely standalone, doesn't require a JVM to run your application. What's interesting, GraalVM is also a very big open source project. So our development is happening on GitHub, and you can see the data. It's not even one repo, but there is a number of repos because it's so big. So there is the core repository with the compiler and other tools. There are language implementations, and there are tools like GraalVM. I even heard from someone that it might be one of the biggest Java open source projects out there. So if you're a Java developer, I encourage you to take a look at it, because GraalVM itself is written in Java. So it should be fairly accessible and interesting for you to understand what is happening in the project. Now, let's talk a bit about what we can do with it practically. So first distinction I want to make with GraalVM, that there is a number of ways how you can run Java on GraalVM. And why I'm emphasizing this is because native image, this ahead-of-time compilation mode, is so exciting that many people only associate GraalVM with it. And when they refer to GraalVM, they usually mean native image. But in fact, it's not the only component, right? So as I said previously, you can run your applications in JIT mode or in ahead-of-time compiled native image mode, and then depends on the performance profile that you want to achieve, and we will talk about which mode of operation you should choose depending on what you want to accomplish. So first thing, or first decision that you get to make if you're running on GraalVM is whether you want to run on a JIT mode or compile ahead of time as a native image. So this is probably the choice that most of people will make, but just for the sake of clarity and giving you the full picture, since some time ago, we now have another way to run Java on GraalVM. I will not stop on it here because it's not the topic of this talk, but if you're curious, come afterwards and I can talk with you more about it. So if you recall, we have all those additional languages like JavaScript and Python implemented on top of our language implementation API. And we also re-implemented Java on top of GraalVM as well, so it can be like a first-class citizen in this Truffle, our language implementation framework ecosystem, and more directly interop with languages such as JavaScript and Python. So in fact, there are even 3 ways to run run Java on GraalVM, but in this session, we will focus on this middle one, the IoT one. So a few things about running on GraalVM as a JDK. So what we did to provide you GraalVM as a JDK, we just replaced the top-tier compiler in Hotspot VM with our GraalVM compiler, and you can just replace your JDK distribution with GraalVM to run your application as R. So without any additional steps from you, you can just run your applications on GraalVM as a JDK as you would on any other one with your Java command. And we have both available for Java versions 11 and 17. So if you're curious in running GraalVM, and using GraalVM for your Java applications, these are the options that you get in the JIT mode. And to illustrate that thought, so I mentioned a few times that we have new compiler, and it's very optimizing, and it can give performance benefits for many, many applications. So to illustrate this thought, here are the measurements done by the Facebook team. So they migrated from OpenJDK to GraalVM, and what they saw and what they accomplished with that is 10% reduction of the CPU usage, just because this compiler is so good at optimizing code and removing unnecessary allocations. So you can imagine that at the scale of systems such as Facebook or Twitter, every performance improvement is very significant because it's multiplied by the scale of the system itself. So here they are getting quite significant performance improvements from running on GraalVM just by basically migrating applications to it. Now, let's talk a bit more about GraalVM native image. So this is that ahead-of-time compilation mode that you probably heard of. And that is when you take your application, compile it with our native image command to ahead-of-time compiled mode, and in the end, you get a platform-specific binary that starts much faster, is way more efficient in terms of memory usage and all resources usage overall. So what happens behind the stage when you're running native image command? Our native image tool will take a look at your application, starting from the main entry point, and we're trying to find all the reachable code to make sure that all the code that is necessary for your application to perform, so all the code that is actually doing some valuable job for your application is ending up in this resulting binary, and also will eliminate all the unnecessary code. So if there is some code that your application is not actually using, so for example, pulling some dependency and not exactly leveraging it, it will be eliminated to make sure that the resultant binary is very slim and only contains what has to be in there. So another thing that we will do as we are analyzing your application and looking for the reachable code is we will perform what we call heap snapshotting. So we will pre-populate heap for you. So when you start your application, it comes with a ready-to-use heap, and this way it also starts way faster and uses way fewer resources because all of this work was already done at the image build time. So basically, unlike traditional execution of Java applications in the JIT mode, you can think of working with native image as of 2 steps. So first, you build the application, and then you actually run it. And the idea here is to move all the heavy lifting from the runtime to the build time. So you can build the application once, do all that heavy lifting, do all that overhead, and not have to do it every single time when your application starts. This way, it can start much faster. And talking about image heaps, so one thing I want to emphasize here, often when people talk about native image, they emphasize the ahead-of-time compilation part of it, and it's very important and very essential to the way native image operates. But another aspect of native image is that it's also a snapshotting technology. So we take a snapshot of your application at the image build time, so you can start faster when you run it. So it's not just about ahead-of-time compilation. It is significant and important, but it's also about snapshotting, so you can start with this pre-populated state and ready-to-use resources when you start your application. And the way to build your native image would be the following. So you run the native image command, and you can choose whether you want to produce a native executable, or maybe you want to do a shared library. And after you build it, you can just run it as a normal native application. So, OK, let's say you are interested in native image, and you would like to get started with it. In fact, I'm curious, how many of you have tried building something with native image? OK, I would say third, approximately. That's good to know. So for those of you who haven't tried anything, there are a few simple ways to start. So probably the simplest way to start is to go to our GraalVM demos GitHub repo, and we have some ready-to-use apps for you that are configured that you can just copy, run on your machine, see how it works for you. Now, if you would like to do something more probably custom, so build an application of your own, I do recommend leveraging one of those frameworks that work great with native image. So the good news here is that many of the popular Java frameworks adopted native image as a platform, and when you're doing applications with one of them, it's very easy to also compile them to native image because they are doing some of the configuration and some of the preparation work for you. So if you want to build your first native application, you can just write it from scratch in plain Java, but I do recommend you looking at one of those frameworks because they will give you a lot of features and a lot of help out of the box. So one of such frameworks is Micronaut. It's a really great framework for building serverless and microservices, but also any kind of Java applications. And it's working really great with native image from the day one. So it was built kind of aware of the native image and the way it works. So it works really great, simplifies configuration and building process quite a bit. And good news is also there is one more talk about Micronaut specifically right after this one from Graham Roche, who is the founder of Micronaut. So I do recommend checking it out. I looked at the topic, looks very interesting to me, so please go and check it out as well. And how you would build your Micronaut application, so two ways. You can use your the MN CLI utility, or you can configure your project at their launch website. Fun fact, if you ever use this MN CLI utility of Micronaut, it's itself a Java application built as a native image. So if you ever have used it to try Micronaut, you already kind of used GraalVM native image under the hood. And to share some measurements, so why exactly native image is great and what kind of performance you can expect from it. So here we have a Micronaut application that's the same application. We are just running it in two modes. So first as JIT mode, and then compiled to native image. And in first mode, and that's basically a web server that is serving some requests. So in first mode, it is starting in something like 3.3 seconds, because there is quite a bit of work to do when your Java application first starts, right? And then when we take the same application, compile it to native, and start as a native executable, you can see how immediately startup time goes down to 0.1 seconds, so much, much faster. And those numbers will vary depending on what exactly your application is doing, but typically you can expect significant speedups like this if you're converting your application to a native image. Now, the first measurement, that is how long it took our application to start, but what exactly about doing some valuable jobs? So let's measure what it would do if we have to actually serve some requests that arrived. So we are measuring that second time, and we see that numbers are comparable in terms that JIT mode takes some time, while if the native image mode, the same task, right? So starting the application, serving the first request, getting it done, is significantly faster. It's 1.3 seconds versus, again, 0.1. And they're doing some extra work to optimize this even further. So what I showed before, it was me measuring it quite some time ago, but also they recently added this Micronaut AUT additional optimizations that optimize startup time even more. And here it's, again, Java web server application compiled to native, and you can see that it started in just 6 milliseconds, which is quite crazy, I would say. So that is startup, and often you care about startup, right, especially in environments such as cloud, but also it could be the case that you care about startup less because maybe you have longer running applications, but you do care about memory because that is something that affects your cloud costs quite a bit. So what about memory? Here, it's the same Micronaut application, again, a web server, and we're comparing how much memory and CPU it is using in those two modes again, so JIT mode and native image mode. And those red spikes, that is CPU usage, while the blue-green line, that is memory usage. And you can see, again, so what we saw before, right, when the application started in something like 3.3 seconds, applies here as well. And the CPU is quite busy those first 3 seconds doing all that work, such as loading classes, starting interpreting, starting compiling. There is quite a bit of work to do when you first start your application. Now, in the native image mode, you can see how much less the CPU is and also how much less memory we are using, because, again, it was compiled, it is ready to use, and it's just ready from get-go when you first started as a native application. And to talk more about this memory usage, so here what we are looking at is a Quarkus application this time. And you can see that if you want to scale the application by adding more instances of that application on the JVM, you can see that it gets massive quite fast, because every single time you would need to add more resources to run this application. While in the native image mode, it still adds some more time every time we add an instance, but it's significantly less because it doesn't require all that additional resources for things like compiling, keeping additional data structures, and so on. And one more cool example, which I like a lot, and cool app that you can build and compile to native is JHipster applications. So JHipster is a project that allows you to easily bootstrap full-blown web applications in Java. It can give you things like Spring Boot and Micronaut and Quarkus on the backend. And then on the front end, you can have things like Vue, React.js, whatever framework of your choice. And they recently added this JHipster native blueprint. And you can see, like, my machine is not the most powerful one, so even compiled to native, it took 0.8 seconds to start, but it's still quite good for a full-blown Java web application. And I think I got it even to start at something like 0.3, which is also nice. So we talked a bit about Micronaut and Quarkus, but just to give you a better idea of what else you can do with native image. So we often get this question about Spring Boot. So can I do native application if I'm a Spring Boot user? The answer is yes. They have this Spring Native project that we are working with them together on. And that also allows you to build Spring Boot applications as native images. So these numbers that we have here they are from Spring 1 last year, and they were still work in progress. So we expect them to share maybe some new ones at Spring 1 this autumn, I believe. But even as work in progress, you can see how much better those startup and performance numbers are in the native image mode. So here on the far left, we see container image size and startup time for the JVM. And on the right, you can see compiled to native, even as work in progress, it is still much, much faster, even for Spring Boot applications, where the Spring Native support is still kind of experimental. And same applies to memory footprint. So I think you can notice the trend, how much faster applications get, no matter which framework you use. So there is still a significant difference between JVM and started in native, and all those metrics, such as startup time, memory usage, packaging size, they go down significantly, basically no matter which framework you use or what kind of things your application is doing. And to talk about container image sizes, for example, here I have a Halidon application. And you can get the container image size to as low as around 20 megabytes for a simpler Hello World application if it is compiled to native. And talking about containers and this kind of cloud deployments, there is one more cool thing that you can do with native image, and that is static and mostly static native images. So you can statically link your native image applications against muscle libc to make them fully self-contained, and this way you do not need any kind of external dependencies, so they will have all the code that is necessary right in your application, and you can use them on slim, on distroless Docker images. Another thing you can do is you could link against everything except for libc, and this way produce a mostly static native image, and it's also very good for deploying on distroless containers. This way you can easily deploy new instances of your application. OK, so this is all good, but can we get more out of native image? And what are some tricks that you can use if you want to run it in production and make sure you're making the most out of it? So one cool thing is profile-guided optimizations. And if you ever looked into how JVM is executing your application at the runtime, you might know that what is very helpful is having this profiling information, right? Because code execution on the JVM is dynamic. So the JVM looks at how your application behaves and what exactly it does, and it can adjust on the go depending on what the application is doing. And this is what makes JVM so powerful in terms of peak performance, right? Because it can adjust on the go and make decisions about optimizing your code on the go. But what about native image, right? So it compiles applications ahead of time, and one important thing to keep in mind is that it is happening under closed world assumption. So to build a native image, you need to know at the image build time everything about your application. So everything has to be known because we build application ahead of time. So in the end, what you get is only machine code, only produced binary, so all the information has to be available at the image build time. So how do you optimize for the best peak performance if you're compiling ahead of time and you don't know yet how your application will behave at the runtime? So one thing that is helpful there is this actually profile guide optimizations. And what it does is that it can allow you to build an application with profile information in mind in a way that you first run the application, collect profile information, and then you feed that profile information to the native image utility so it can build and optimize your application for this specific behavior, for this specific profile. And this way, you can achieve really great performance of the native image applications, and we will get to that in a second. So talking about optimizing performance even further, since a while ago, there are also a few GC options available in native image. So by default, what you get is serial GC, which is good for kind of shorter living applications. Another option that you can get is G1 GC, and it's very helpful if you want to optimize for better peak performance. And just as another option, you can also get Epsilon GC, which doesn't perform any GCs at all. So you do get those options, and by combining them in the way that, for example, if you're using PGO, so profile guide optimizations, and G1 GC to optimize for the best peak performance, you can get really close to the peak performance of running on Hotspot VM. So this was also a common kind of question and request from the community. So native image is great for starting fast, memory usage, but what if I care most about peak performance, right? So what do I do in that case? And here you can see we ran a wide range of benchmarks, so Renaissance and the Kappa benchmarks. And with PGO enabled and G1 GC enabled, you can get really close to the performance of running on Hotspot VM. So you're not losing much in terms of peak performance, but you get significant benefits in terms of startup and resources usage. And another aspect is that if you want to optimize the packaging size, right, so if for whatever reason you want to make sure that your application is as tiny as it can be, so maybe it's easier for you to deploy it to other machines, you can use the tool called UPX to compress your application even further. And as an example here, you can see Julian compiling a Spring Boot application, and it got the size of it to go from 60 megabytes to just 17, which is quite good. So if the packaging size is something you care about, make sure you can check out the UPX. So it's really helpful for that. And what if you want to monitor performance of your native image applications, right? So are there any tools you can use for that? Yes, since a while ago, since a couple of releases ago, we also support JFR, and that is actually something our team at Oracle Labs developed in collaboration with Red Hat. So big thanks to the Red Hat folks for that contribution. And you can build a native image with this GraalVM inspection flag. And then when you run it, and again, enable JFR recording, you can get to that JFR snapshot and analyze it in a tool of your choice, such as, for example, GraalVM. Let's see if I can illustrate that thought. OK, so what I did here, I built my native image. Where is the command? OK, so I did native image, again, use this flag GraalVM exception, and gave it my Java application. So it built my application with this VM inspection option enabled. And then when I run it and I say that I want to start a recording and give it the name of the file where I want to put my recording into, I will get this recording JFR file. that I can analyze, let's say, in Visual VM. And it is still kind of a work in progress. So this was released a couple of releases ago. But you can see that you already have some events that you can track with JFR from native images. Such as, for example, here I can see quite a few things about my system. I see that the VM I used is Substrate VM, which is the name of the tiny VM implementation that goes into native image. I also see things, for example, like I use GraalVM 22.1, so that is my GraalVM version, some other properties. And what is also cool, we can add custom events. So if you want to track something specifically in your Java application, you can add a custom event for that, and it will be also tracked and recorded, and you can later analyze it to understand better and optimize performance of your native image application. OK, all good. Now, a few more things about native image. So I don't have that much time, but if you want to learn more about it, specifically about configuration and how it works with different frameworks and things you need to know about things like reflection and so on, we have this guide on InfoQ where you can read more about it, and I recommend checking it out. And another helpful tool, if you will be working with native image, is that we have those official Maven and Gradle plugins from our team that simplify building native image applications and also introduce JUnit support for testing native image applications. Now, what is new and cool in GraalVM and native image? And I'm very excited about this part because I care about developer experience a lot, and we've made a lot of changes in this area in GraalVM in the last couple of releases. So one thing is quick build mode. So when you build in your native image application, as I said, it starts really fast, but the build time, so when you're actually producing the binary, can take quite some time and resources because typically Java applications are bigger and there is a lot to analyze. So native image has to analyze everything your application is doing, include all the information, find all the reachable code, then optimize it, then compile it, and then produce this native executable. So you can imagine that it's quite a bit of work, so it's no wonder that it takes some time, but again, it is simplifying the startup time for you. Still, it was a common request from our community, can we do something about build times, can we improve them? And yes, as of last release, we have this quick build mode. So when you're building a native image, you can pass this OB flag, and it will enable this quick build mode. And what it does, it performs fewer optimizations during the compilation stage of the build time. So we recommend using this build mode only for development purposes. So this is specifically developed for development purposes. And as the result, compilation time gets significantly faster, and the overall build time gets significantly faster as well. So compilation is just one stage of the image build process, and we are in this quick build mode, we are specifically optimizing compilation. And you can see here on the right, that is us measuring how fast we are compiling libgraal. So that is our GraalVM compiler, which is itself a Java project, and we compile it with native image to produce a native executable file of it. So we're kind of using native image internally as well. And you can see that that orange chart, that is matter of compilation time, and it got something like 5x faster when enabling quick build mode. And the overall impact for the total build time is also something like 2x faster. So check it out if you build native image and you care about build times and you want to make them faster. But as I said, this is something considered for development purposes. So if you want to actually deploy your application, so when you are ready to deploy it to your users, make sure to use normal build mode because it is optimizing for peak performance. So for development purposes, where you just want to validate that everything is working correctly and get faster results, quick build mode is really helpful because it's optimizing for that, but at the cost of peak performance because this is just a development mode. And this is something we will keep working on, so we want to make sure we also optimize for better peak performance even in this quick build mode and see if we can speed up other stages of the build process as well. But check it out if you want to have faster build times for your native image applications. Now, another thing, this is a separate thing from this quick build mode. We are also optimizing like a normal, regular build times. So over the time, you can see how it got significantly faster. This is on the example of Spring Boot application. So we are always working to make sure you can build applications as soon as possible because we understand you want to get results faster and make sure you don't spend much time building applications. And another cool thing, so we now have this also new build output. So when you're building a native image, there is a lot of happening, right? So we are analyzing the application, we are compiling it, we are inlining methods, and to give you a better insight in what is happening and what is included in your native image, we are now having this new build output where you can get more insight and see if you can optimize certain aspects of your application or your build process because you have more data to do so. And another thing is that we also have GitHub Action for GraalVM. So if you're using GitHub Action workflows, it's fairly easy to set up GraalVM, both Community Edition, Enterprise Edition, make sure it works well in your GitHub Action workflows too. And the last thing, so if you are a happy, lucky Apple M1 machine owner, we also have builds for you now. So this was surprisingly a highly requested feature from our users. But yes, we finally delivered this in the last release, and there was a lot of community help and work happening on this ticket. So if you're an M1 user, make sure you can use GraalVM as well. And the last thing, this is super new. So I think they announced this last week or so. So with the latest early preview build of IntelliJ IDEA, you also get access to debugging native image executables in your IntelliJ IDEA. So for that, you would need to get this specific build and also developer build of GraalVM and native image debugging plugin for IntelliJ. But great news is that this is now possible in IntelliJ IDEA, and hopefully soon it will land into normal builds as well. So now it's experimental, but if you are curious about this, please give it a try and provide feedback to IntelliJ folks. Now, a couple of things. So what is next for native image, and what are the next things that we will be working on? So one thing is we want to extend platform support, make sure we offer full support on all the possible platforms. Another thing is we care a lot about making sure that the Java libraries in the ecosystem are compatible with native image, and we want to make sure that the compatibility and configuration for Java libraries are as easy as it gets for native image. So that is one of the things we are working on, in particular with various folks in the JVM ecosystem. Also working with Java frameworks to make sure all of them can leverage all the latest native image features and tools, and improving performance of native image in various aspects. So improving that quick build mode I talked about, further improving GC performance, and making sure you can get the best developer experience and the best performance in native image, no matter how exactly you are using it. And a few things I want to mention about polyglot superpowers of GraalVM, because it's very exciting and I like it a lot. So you remember all those different languages that you have on GraalVM. And the best thing is that not only you can use each of them on GraalVM as one thing, but you can also mix and match them. So if you want, let's say, some particular library from R to, I don't know, do data science things, you can easily embed that R library in your Java application and leverage it to produce plots and do other data science things in your Java application from R library. And GraalVM not only enables running all those things, but it also takes care of the optimizations and across languages, right? So it will optimize and compile the application in a way that all of the languages and all of the parts of those languages are working with the best possible performance. And a few things about specific languages. So we have great JavaScript implementation, which we keep up to date with the latest ECMAScript standards, and we constantly test against thousands of modules to make sure we have full compatibility and you can easily work with JavaScript in GraalVM. And one of the common cases where we see people using JavaScript on GraalVM is to do server-side rendering. So you can have just GraalVM on your backend, you can run Java on it, or if you have JavaScript on your front end, you can perform server-side rendering as well. And this way you can get better performance by leveraging those two languages at once. And another cool example is from Oracle NetSuite team. So they had this huge Java application that they wanted to enrich with recommendation system kind of features, and the best kind of libraries that I found to provide those recommendation systems is in Python, right? Because Python has a lot of great machine learning libraries, and what they wanted to do is to leverage those Python libraries from their Java application. So what they did, they just used GraalVM as runtime, embedded those Python libraries, and they were able to leverage Python libraries to build this recommendation system. And one cool thing, so you can see the block called grCUDA here. So another thing you can use, and they used it in this example as well, is to use this grCUDA project to also leverage GPUs to make sure your workloads, and especially things like ML kind of workloads, have the best possible performance by leveraging GPUs on your machine as well. And talking about using native image, this is just to illustrate what kind of performance benefits you can get from native image, and in particular in the cloud. So this was folks from Alibaba. They shared how they moved their applications to native image and how they got them. I mean, those are very big applications, right? So you can see on the left that they were starting in something like 60 seconds, I believe, on the JVM. And with native image, they start in 3 seconds, which is maybe not as fast as the examples I showed you before, but that is still quite a significant startup improvement for a big application like this. And this is a more recent example. So these folks are also using native image, and what they shared is they got their container image size significantly smaller, so from 1 gigabyte to what was it? To under 50 megabyte, and the startup time is way faster, so from 15 seconds to something like under 1 second as well. And very quickly about this one. So I talked about different aspects of native image, such as startup time and memory usage and packaging size. But these particular folks, what they emphasize about using native image is the improved security. And this improved security comes from the fact that when native image is compiled in your code ahead of time, it eliminates all the unnecessary code, one. So if you are pulling some random dependency that you're not so sure about, but you're not exactly using that code, native image will eliminate it because it will see that it's not reachable, so you're not exactly using it in your application. And also, since GraalVM native image compilation happens ahead of time under closed world assumption, no additional code can be added at runtime, again, improving security, because that is just not possible, right? You compile it ahead of time, you have your final binary, and no additional code can be added at runtime. So here they specifically emphasize that all that startup and memory usage is great, but they particularly appreciate that they can also improve security by using native image. And to talk about roadmaps, so if you are following GraalVM and you want to see when is the next release and when you can get access to new features, we have releases 4 times a year. So every 3 months, we add some new features. The next one is coming in July. And also, we have developer builds. So if you're feeling adventurous and you want to try all the latest and greatest stuff, you can also get our developer builds from GitHub and see the exact latest features that we just delivered and that just ended on the project. So to get started, if you want to use GraalVM, you can go to our website, graalvm.org. That is like one-stop place to get all things GraalVM, so downloads, community, resources, documentations, all kinds of things. And if you need help, we have our Slack space where we are very active and we have plenty of people asking questions and getting help there. And if you would rather get just news and follow what's new in the project, you can follow us on Twitter or on mailing list if that is your preference. With that, that's it. I will be around for questions for some time, and also I have stickers. So if you want to ask a question or if you want to get a GraalVM sticker, please come here and I will be happy to help you with that. Thank you.